popular time to have lots. So I would expect there's probably a decent amount of people that are in that situation. Do you have class on Monday, Elizabeth?
No, I have no Monday other classes.
Yeah, no. I know there's at least three. I can take a 3 or 4 up.
Who gets your food?
Do I have a good food you pay?
Oh yeah, he's a weekend.
I think he's been here for about a year.
Yeah, it's pretty good.
Yeah.
Do you know Andrew? Andrew Hertzberg?
I mean,
He's in my robo and he's in class.
Okay, so they're all set.
All right, let's do it.
So today we'll look at the propositional logic part. So I prepared this problem. I don't know how much interesting it is, but yeah, I think it should cover a lot of concepts. This is our problem, where the knowledge base consists of the 3 rules that B goes to movie, if A goes to movie, C goes if B goes, and C doesn't go if D doesn't. Okay. So, and we want to see whether D goes to movie if A goes to movie. Okay. So the first question is basically to write propositional logic sentences for each of them, and then we'll try to answer it by model checking.
Are we going to go over entailment?
Yes, everything.
And resolution?
Yes. So I want you guys to try and attempt to write propositional logic sentences. So it's basically the first one is kind of
If A goes to movie, then B goes to
yeah. So basically, if A goes to movie, then B goes to movie. Something like
Okay, yeah.
What will be the second one?
Yeah.
Yeah. So A or B implies C.
Not A plus not C.
Right? Yeah. If B doesn't go, then A doesn't go. Also, C doesn't go. So this is our knowledge base. And we want to see whether this entails
So A implies D is what we're trying to find out.
yeah.
So we start from the back, right? And we
So first we want to attempt very simple model checking. Which means basically let's have truth tables for all the stuff.
oh,
Truth first, right?
okay.
So we have A, B, C, D. We have just to appreciate the things that are yet to come.
Keep track of all that.
Too busy. So we want to see where all A implies B holds. Right?
Sorry, just give me one more second. Okay. Speed. So that's true. First one is true.
First one is true.
Mhm. Second one is true.
Second one is true.
Third one is true. Fourth one is true. And then false. Yeah. Okay. Yeah. Wait, I forget, not A implies not B? I mean, not, what does that mean? Why is the last four true again?
So this is the one. This is basically what we are doing is this. We
Yeah.
are evaluating this.
Okay.
So not A or B.
So
So
not-
not A is true for all these cases.
So then it's true. Okay. That's right. Okay, so now we need to do A or B, C.
Yeah, let us just do A or B
Oh,
first,
yeah.
probably. Then we have these. Then
It's only not true for the last four.
Yep.
then now we are looking at A or B plus C, which is basically not of A or B or C.
Yeah. Okay.
You are also
So-
in this class?
Oh no, she's with me. Sorry.
Sorry, is it okay if I sit in?
Yeah, I was just new face.
Oh yeah. Yeah. Okay, so the first one is true
We have
because C is
not
true.
of this or this, right? So
Yeah. Yeah. False. False. The last four is true. True, true, false, 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 true.
then we have not D implies not C, which is basically D or not C.
D or C. D or not C. Yeah. Okay, so D is true. So
Goes here.
and then yeah, this is true too. False for the fourth. So the second one is true and the fourth one is false.
Not C. Yeah.
D is false and not
Not C is also false. This is actually false, right?
Oh yeah, that's what I meant.
Yeah. So same with here.
Quick. Okay.
So our knowledge base contains all these three, which means all these three should be true. So we are interested in this and this.
Wait, I have a question.
All the first ones, I think.
I have a question.
Yeah. That's it.
No, not B.
No? This one?
Not A.
Where is it wrong?
A plus B.
Here? So not A or B. It's false, right?
So it will not be multiple.
Which one is it? This one?
A plus B is false, right? For the fifth.
Yes, yes.
So it will not be knowledge base.
It will not be a.
It will not be knowledge base.
This is just for help. Ultimately these three are the ones which are in knowledge base, right? Oh, sorry.
That one too.
Yeah, this one not. Sorry.
The fourth one also.
I'm sorry.
Nothing. Yeah. Okay.
This is just for help. So this we are not really interested in. Yeah, I think my bad.
So only where the first, third, and the fourth are true.
Yeah.
Okay.
Yeah. So let me just. Yeah. Thanks for pointing out this. Okay. So yeah, let me just put tick marks. This one is a knowledge base. This one is a knowledge base. This one is a knowledge base. And these two are knowledge base. Right? Is this clear?
So as our alpha, the A implies B.
Yeah, so we're getting to that. That also we need to list. So it's just that, if this one is empty, that would be automatically true, right? If the knowledge base itself is empty, then. So now we have to see what happens with A implies, which is not A or B. True.
Oh, you have to do all of them? I thought you just had to do the ones where it was true. You have to do all of them, or I thought you just had to do the...
Yeah, we could just do these.
Okay.
Others, yeah, that's a good. That's a good. So here it's true, and here.
A, D, no. Yes,
Not
it's
here
true.
or-
F and T, so yeah, it's true.
It's not here D. Not here D. Fine. Not here D. False.
What is,
Not here is true. Oh, okay. Sorry. This will be true because of not A. This is true because of D. This is true because of D.
Oh. So it's knowledge based. Okay.
So, what is the answer? Does this entail this?
Yes.
Yes. Basically, we are concerned with what are all the worlds in which the knowledge base is true. Is it the case that this is also true? That's it.
So, yeah, so what does that mean though? I understand the process, but what does that mean? So where the knowledge, the world in which the knowledge base is true is where alpha is also true?
Yeah. So basically, we have certain knowledge about the world, which we have represented in these terms, and we want to query we want to know certain things about the world. This is what we want to know about the world. So by doing this process, we'll determine whether this is true given this or not.
So now we can add that to the knowledge base, right?
You need not. It's
No, I mean,
just redundant.
if you had a separate now another thing you wanted to add and you wanted to check it against that could be part of the knowledge base that you use.
Yeah, this could be a helper,
Okay,
but
yeah.
this doesn't really add any value because this could be deduced by this.
Oh, I
number.
see. Okay. Yeah. Okay.
So this is the most basic way of how proposition logic works. This is obviously lengthy, things like that. So we will now move on to resolution theory.
The better one. Because we don't have to.
We don't want it.
I said it's the better one because we don't have to do this.
So,
Oh, yeah.
so how do we simplify this?
So you start at the end and you negate the conclusion,
Yeah.
right?
So before that, we need to basically convert this into CNF form,
Oh, yeah.
conjective normal form. Only then we can do apply the resolution rules.
So what is CNF? What is
CNF is basically conjunctive normal form. It's basically and of ours. Okay, that's how you can remember it.
I thought it was Chomsky normal form.
That's for randoms.
Yeah, I thought that was the same thing. Is this not what we're doing? Oh, okay.
So here we
Why
have
didn't
basically
you-
CNF side DNS.
It's the same abbreviation. Yeah.
I have if we do that the inference rule is containing the knowledge base, then can we use that inference rule in proof checking?
Yes. So
Like here, A and then A plus D is the rule which we derived, right?
yeah.
So can we use A plus D in the model proof check as a resolution rule?
Through resolution? No. No, we have already proved it. Okay. There is nothing more to do actually.
We have one more inference
No,
rule,
no,
right? So
no.
can we use it in that?
No, nothing more to use. If we use this, ultimately if we know this, then there is nothing to prove. Okay. Now it's all about, it seems like too much of a lengthy process. How do we reduce the complexity of this? How do we improve upon our method to determine the truth or falsity of this? So now, once again, the problem starts from scratch. We don't know anything about this. If we know this, then, this implies this and everything is done, right? There is nothing more to do.
Like, by chance, like, if the question is like B plus D should be proved.
Uh-huh.
Now, we already proved A plus D.
Yeah.
So can we use that A plus D?
Sure, that's what we see in the inference rule derivations also, right? We have so many things that we get to in the middle. They are all true. And based on that, we ultimately prove whatever we want to do. So, yeah, using this is fine, but it's like a mix and match of algorithms. For some parts, we have used this. And firstly, how do you determine that this is the one which will be needed for B plus D? that's another tricky thing. So, yeah, as a method, you won't be able to determine what will be needed for B implies DC. But as theory, this is a valid thing to use whenever you are using this. So first we have to convert these things into CNF. And how to do that?
I forget.
Oh, so this one translates to basically, yeah, as I was saying, it's
Saying
and of parts, right?
And.
So we have so many R's, right?
Uh-huh.
Something
Not A or B. Convert that to
something
and.
like that, and of such things. Right? So this is basically CNF form. And we want to convert each one of these into such form. So this one translates to not ARP, right?
Mhm.
In this way, right? This is one R form. So this is a valid way.
That's it?
Yeah, this
Oh,
is
okay.
CNF form.
Okay, it's already in CNF.
And second one is similarly if we put this not of A or B or C. So such things are not allowed. Okay, you can't have negation at high levels. Negations should be associated with directly with the terms. So this we need to expand. So this is same as not A and not B or C. This is democracy.
That's still not correct, right? So is that correct form then?
No, right? This is or of ands
Yeah.
kind of thing.
Okay.
But we want and of or.
And of or is, yeah.
So this will further not J or C.
Okay. That's good.
Yes. Now it looks like and of ours. And all the negations are only at the terms.
Not.
Can you tell me for 3?
So it'd be D or not C.
This is D or not C. And everything looks fine.
And that's fine, yeah.
Because negations are at operations. And go.
What's G?
Yeah. That's the
Oh,
goal.
okay, cool.
Okay, so this is how we write the knowledge base and the goal in CNF form. Now we can do apply resolution rules on this and see whether this can be achieved or not. So how do we do that? So I'll erase this. That's okay, right?
Mhm.
quick question. Do you know if we have a test next week?
Do you guys have a test?
Do you know?
I don't know actually. Do you have? Do you know?
It's not officially announced, but in the PSI it's written as exam and
That's a
question.
question mark next to
So,
it.
I don't know. So did Maybe tomorrow Rahul will say. Tomorrow we'll have
Okay. All right. What do we do now?
So, how do we, answer this using brute force strategy or, breadth first strategy, whatever it's called. Basically, it's kind of brute force, right? It explores all the. So we basically take negation of this and see whether the entire thing makes sense or not. Is it consistent or not?
Is this resolution?
Yeah, this is resolution equilibrium.
Oh wait, so the other way, aside from model checking, is resolution?
No, yeah, the other way of doing it. Yeah.
Yeah.
Ultimately, we want to, know the validity of this theorem. Is this theorem valid or not? And one way is model checking by first principles. And more compact way, faster way should be, through resolution. And the way we approach is this: we assume that it's false, and show that, then it's inconsistent, which means it should be true. That's how we
Yeah.
approach.
If it makes sense, that's bad. If it's true, then that's false, right? Then the
So
whole thing
if
is
this
false.
is false,
No, if this thing is true, that's bad. If we negate it and then
Yeah.
it's true, that's not good. That's inconsistent.
if we negate it and then if it's inconsistent,
Yeah.
which means we
It's
shouldn't
true.
have negated in the first place. Which means
Oh,
it is true.
no. If we negate it and it's not inconsistent, then that's bad.
Yeah.
Yeah. Okay. Got it.
So our objective is to negate it and show that it's inconsistent.
Okay. Cool. Okay.
You
So
negate
So-
not A or B.
so A and not
yes.
D.
First we need to negate this. We can call it pole or theorem. Okay, if we call it theorem, then negation of P is basically negation of not A or D, which is
A and not D.
A and not B. So now we have 1, 2, 3 and 4. And we want to see that, whether that is consistent or not. Okay. So here there are basically, as Rahul discussed in the class, there is a thing, right? If this is itself is inconsistent, then this will always be true. Because, it's anyway there are no worlds in which this is true. So whenever this is true, then everything else is true. By, this. And
Say it again,
so if this itself is inconsistent, it means that there exists no world for which this is true. Which means in all the worlds in which this is true, anything else will be true anyway. Because in the first place there is no world. Right? So first thing, brute force method is that it doesn't matter whether it is given that this is consistent or inconsistent. It will always work. That's the beauty of brute force method. And as we go to the next methods, we will see when they work and when they don't. Okay. So how does brute force work, strategy work, right? So we write down all the CNF formulas, not A or B, not A or C, and not B or C, not A or D, and A and not B. So So I just wrote down all the things: 1, 2, 3, and 4.
Third one is DR not. Third one is DR not.
Oh, DR not. Sorry, that's what I was wondering. What is this? Thanks. Okay. So all these terms are considered separate. So you can drop this, okay? Because ultimately it's this and this and this and this. You are looking at the consistency of everything together. So you can drop these ends. Okay? So you are looking at consistency of these 6 terms. Alright? So how does brute force search work or vector force search work? So you try to combine this with all the other guys. You know, this is first level. And at second level you will write all the combinations of this with everyone, and so on. So this and this can't combine. How does the combination rule work? So if we have something like, you know, x or y and not y or z, then this will translate to y or z. So this is the resolution rule. We try to apply it with every combination. This and this and so on. So is it applicable here? No, we don't have y and not y structure between these two. So nothing to write. This and this, we have it. B and not B goes and it becomes not A or C.
So we draw like a line to each of them.
Yeah, you need not. Doesn't
Well,
really.
might help.
Yeah.
Or else they'll know which two you took.
Okay.
Okay. There we go. Perfect.
Then you try to do these two, won't work. You try to do.
You can do the second one and the fourth one.
Yeah.
Yeah.
You can do this. And
Came
yeah,
from-
let us finish with this one first.
Oh, okay. So you just do start with the first one and
First
do it.
one and do everything.
Okay.
Second one and do everything onto the right.
Came from the first and the third one.
So wait, why'd you get rid of the conjunctions?
So we are looking for consistency of everything together.
Let's-
So we actually are looking at consistency of this and this and this and this and this and this and this. We are anyway looking at the entire thing together. So we can just drop the ones which are, you know, were in the first place.
So that's the reason why you dropped the conjunctions?
Yeah. Basically, effectively, we are anyway considering the conjunction of everything. So first you can put conjunctions where nothing is there, and then you can drop everywhere. That's another way of looking at it.
That's
So
it.
these two are the ones with this.
Yeah.
What about this? So backward we already considered. This one combinations are everything. So we just need to look to the front.
Okay.